Have you ever really thought about what's inside your phone? Well, today, we're going to peel back the layers and trace the incredible journey from a simple grain of sand to the powerful microchip, the superbrain that runs your entire digital life. So let's just start with a number that's, well, it's pretty hard to wrap your head around. The chips inside just one modern smartphone can pack in a mind-boggling 90 billion transistors. That's more than 10 times the number of people on Earth, all packed into a device that fits in your pocket.
And here's where it gets even crazier. Each one of those transistors, the tiny little on-off switches that are the heart of all computing, is just a few nanometers wide. To give you some perspective, that means they are way, way smaller than a virus. We are literally building our technology on a biological scale.
All of this incredible density means that a tiny little chip, smaller than your fingernail, has more raw computing power than the huge room-sized supercomputers that guided the Apollo missions to the moon. Just let that sink in for a second. Okay, so that leads to the big question, right? How on earth is this even possible? How do we actually manufacture these things and build structures at an atomic scale with almost perfect precision? The answer starts in a surprisingly simple place. See, to really get how a chip is made, we can't just start with the chip. We have to go all the way back to its humble beginnings. We have to understand the world that gets built on a chip. And believe it or not, this entire high-tech journey begins with one of the most common materials you can find anywhere, sand. But of course, as you're about to see, this isn't just any old beach sand. It all kicks off with something called quartzite, which is basically a really, really pure form of sand. This stuff gets melted in a furnace at absolutely scorching temperatures. We're talking around 1700 degrees Celsius, which is hotter than lava. It's that intense heat that forces the pure silicon to separate from all the oxygen.
From there, the silicon goes through a whole series of intense chemical purification steps until it reaches an almost unbelievable level of purity, 99.99999%. So why all the fuss? Well, because even one single stray atom in the wrong place can completely wreck a transistor. And we're about to build billions and billions of them. This super pure molten silicon is then meticulously grown into a perfect, gigantic single crystal. It's called an ingot, and it can weigh over 100 kilograms. Then that flawless crystal cylinder is sliced into hundreds of perfectly thin, mirror-smooth discs that we call wafers. And this is where the real magic, or maybe alchemy, starts. A raw, blank silicon wafer might only cost about $100. But fast forward 3 months, after all the intricate manufacturing, and that same wafer, now covered in hundreds of tiny CPUs, can be worth over $100,000. It's truly one of the most incredible value-add processes in any industry.
So, how does that perfect, blank silicon mirror actually get turned into hundreds of powerful little computer brains? Well, this is where we get into the really complex part, baking the brain.
Honestly, the best way to imagine chip manufacturing is to think about baking the most complicated cake in history. Seriously, we're talking about an 80-layer cake with a recipe that has almost 1,000 different steps. And the pressure is immense. One tiny mistake, a single flaw, can ruin the entire wafer, costing thousands and thousands of dollars. The core technology that makes all of this possible is called photolithography. Really, at its heart, it's kind of like developing an old-school photograph, but on a ridiculously small scale. It uses super-focused ultraviolet light to project and essentially print these impossibly intricate circuit blueprints onto the wafer, one layer at a time. And this slide really breaks down the basic cycle that just gets repeated again and again and again. First, you deposit an insulating layer. Then you add a light-sensitive chemical called a photoresist. You use a blueprint or a photomask to block some of the UV light, which patterns the layer. Then you use chemicals to etch away the parts you don't want, creating these tiny channels. You fill those channels up with copper to make the wires. And finally, you polish the whole surface perfectly flat, and you're ready to start the next layer. And remember, that was just for one layer. To build up all 80 or so layers that make up a modern CPU, a single wafer has to go through some version of that cycle a whopping 940 times. The whole process, from that blank wafer to a finished product, takes about 3 months to complete. Okay, so we've seen this incredible, painstaking process for how a chip gets built. But what's it all for? What are these billions of transistors and all these miles of microscopic wires actually doing inside your devices? It turns out it all comes down to a process that sounds pretty simple.
Inside every single CPU, from the one in your watch to the one in a massive supercomputer, all those billions of transistors are just working together to perform a very simple but insanely fast three-step loop. You can think of it as the CPU's heartbeat.
This is it, the fetch, decode, execute cycle. And it is the fundamental rhythm of every processor out there. It fetches an instruction, it decodes that instruction to figure out what it's supposed to do, and then it executes the command. Simple, right? Except it does this billions of times every single second.
A good way to think about it is like a lightning-fast robot. It fetches the next step from its recipe book, which is your program, decodes what it's supposed to do, and then uses its built-in calculator, the arithmetic logic unit, to actually do the math or perform the task. The absolute magic is just the speed at which it does this, over and over and over again.
You know, when you take a step back and you look at this entire process, from a simple grain of sand to a machine that can perform billions of tasks a second, you start to realize that this technology has completely reshaped our world. It's become the engine of, well, pretty much everything.
Yeah, this technology isn't just for our computers anymore, not by a long shot. It's the hidden engine that powers almost every part of modern life. It's in the phone you're holding, it runs the safety systems in your car, it's in life-saving medical devices, and it's the absolute foundation of all artificial intelligence.
And all of this happens inside some of the most advanced and meticulously clean factories ever built by humans. These clean rooms are enormous. We're talking bigger than multiple football fields. And they are thousands of times cleaner than a hospital operating room. And why? Because at the scale we're working, a single speck of dust is like a giant boulder that can completely destroy an entire chip. It's just an absolute testament to human ingenuity.
So this technology, it's the bedrock of our entire digital world, and it's all built with a level of precision that feels like magic. Which of course leaves us with one final, pretty exciting question. We have figured out how to build things with individual atoms. What incredible worlds are we going to build with that power next?